Hi, everyone. Welcome. My name is Jennifer Buxton, and I am with the Office of Engagement. And I'm here to share FLIRT today. So we're doing FLIRT, and the FLIRT is Friday Light Informal Research Talks. And they are a space for Grenfell researchers and special guests to share their work with others. All are welcome to attend. And this upcoming academic year, we are doing online presentations. And today we are talking about open space, dark sky preserve in Gros Morne National Park. And our two presenters today are Dr. Svetlana Barkanova, who is a professor of physics with Memorial University at Grenfell campus. She hosts a program in subatomic physics and astrophysics, supported by one of the largest campus-based telescopes in Canada. She's internationally renowned researcher, and she was on a quest to discover and understand the basic laws that govern the universe, such as the nature of dark matter, internal structure on the protons and neutrons, and fundamental symmetries. Dr. Barkanova is also an award-winning teacher and enthusiastic science promoter, leading a novel science outreach program for underrepresented youth in Western Newfoundland, especially girls and Indigenous students. She is joined by Angelina Payne, who is a public outreach education officer for Parks Canada sites in Western Newfoundland and Labrador. She has been with Parks Canada for 20 years, and she loves to teach, loves it as much as the first day she showed up at Gros Morne. Working on the Dark Sky Preserve was an educational and exciting challenge, and as Gros Morne National Park moves towards dark sky compliance, she looks forward to the day when the Royal Astronomical Society of Canada announces that the park is the newest dark sky preserve in Canada. So I will be passing this on to Svetlana, who will start the presentation.
Hello. Hi. Thank you, Jennifer, for a great introduction, and thank you for inviting me. And thanks to everyone who is joining us right now. As you just heard, Grenfell campus is a proud host of one of the 5 biggest observatories in Canada, campus-based observatories in Canada. And we're very, very proud to make it accessible to everyone, from our own students to the general public. All right, I am going to share my screen now. Let's see. How's that? All right, great. So I'm going to start. I'll be talking for about 15-20 minutes, and then Angie will tell you more specifically about the work we are doing in the Gros Morne National Park, and then we will be happy to answer your questions. This is our lovely observatory, and this is what it looks like inside. This is a fascinating equipment. We have fully storable telescope with 6 centimeters mirror, which gives you the light collecting power of about 10,000 times than a human eye. And normally we have about 1,000 visitors per year, but obviously not this fall, unfortunately. But we are doing webinars like this one, and we also have all kinds of webinars which you can find on our Grenfell Observatory events page. We are not only offering observational sessions for astronomy, we're also doing all kinds of activities, trying to promote science as engagement between culture and arts. Here is a youth group which we had on campus last, for example, presenting sky stories. And here is a youth group, which girl guides, grade 11 and 12, which also visited our campus last year. Again, nothing like that this year, but we are doing webinars. And as Angie is going to tell you a little bit later, we're also hosting live night sky viewing events in the Gros Morne National Park. So here's a one. It's really hard to take good photographs because obviously it's dark. And yeah, most of the time it is cold, as you can see people dressed in jackets, but it's worth it. It's so much fun. Gros Morne, it's such an amazing site. But again, Angie is going to tell you about it later. Here's one of my favorite stories, Moon and the Seven Bird Hunters. Anybody recognizes the shape of these constellations? This is Ursa Major, Big Bear. And this is a beautiful Mi'kmaq story about 7 hunters chasing the bear across the sky as the season change. And that is one of the greatest stories to tell as you actually observing the skies. That's one of my favorites. Our universe is a dynamic, fascinating, and beautiful place. I hope you all agree. But physics is sometimes perceived as being dry, irrelevant, and lacking cultural engagement. That is unfortunate. We are working to change that. Again, our universe is beautiful. So in my work as trying to change perception about physics, I do have 2 very powerful partners, our beautiful universe and our absolutely fascinating local culture. We are working in partnership with Grenfell Campus and CERC Promo Science, which is funding this project, Kalipo First Nations, Parks Canada, and Newfoundland Hydro. So this is a comprehensive scientific and cultural outreach for youth in Western Newfoundland, especially rural youth, girls, and Indigenous students. And we do all kinds of activities. We feature female Indigenous role models. We engage Indigenous storytelling. We discuss wide range of career-related career opportunities. By the way, we've done several webinars on that already, and we're having more planned. If you just go to Grenfell Campus Observatory, you can Google Grenfell Observatory and go to events. You'll see the schedule. We have a lot more planned for this fall. Let's talk about physics for a moment. I'm a physicist, and this is, of course, my favorite science in the universe. Just look at that. Physics is enormous. We have acoustics, astronomy, astrophysics, cosmology, atomic, nuclear, and so on and so on. I was trying to do an alphabetic list for a while, and then I just gave up. But what I was trying to get to it here is that physics is huge, and it can be as practical as you like. For example, medical physics, chemical physics, or it can be really out there like relativity and string theory, your pick. And if you're a high school student considering your education this year, you don't have to decide right away. Just take physics, take math, take a bunch of sciences, see what you like most. Again, physics is huge. There is a lot of choices. Astronomy is a part of physics because it is science about our physical universe. When you look at Orion, for example, this is one of my favorite constellations, look like a butterfly. All what I see here is physics. Just have a look. That star is red and that one is blue. Why is that? Physics. Because this one is not as hot. Blue stars are typically much more hotter. That's how thermonuclear fusion works. That's how physics works. All stars are gigantic thermonuclear fusion engines, our sun included. And yes, there's a lot of beauty in the night sky, but there's also a lot of physics. And for me, again, I could be biased, but physics is beautiful. Astronomy, by definition, is the scientific study of the physical universe and the objects in it. Just think about it for a second. That means, well, everything. Stars, planets, supernova explosions, galactic collisions, all of that is astronomy. It comes from Greek astronomia. So astro is star and nomia distribution. Originally, astronomy was pretty much about distribution of stars in the sky. Right now, it is much, much more than that. It is physics. Let's have a look at the evening sky map for today. So what we have happening now, we have Moon near Jupiter and also near Saturn. You can see Saturn and Jupiter in the evening sky. Jupiter is very bright right now. You're not going to miss it. Just look southwest, you'll see Jupiter and Saturn right next to him. Another fascinating star right nearby is Antares, heart of a Scorpio, beautiful orange star. And if you look straight up, you'll see Altair, Deneb, and Vega. Just try that. Next time we have a clear night, look up. Altair, Deneb, and Vega. The way to know which one is which, the brightest one of a triangle is Vega. And then Deneb, it is located in Cygnus. Cygnus is a swan, also called bird flying from the Milky Way. And Altair is an Aquila, another bird constellation, the eagle, also flying through the Milky Way. This is the Milky Way. This map is free, by the way. You can download it from skymaps.com. Just type in skymaps.com and you can download a sky map, detailed sky map like that with a calendar for every month. So this one is for August 2020, and on September 1st you can go and download the new map for September. Sky is constantly changing. Some of the constellations you see in August are no longer going to be here in September, so you may want to have a new map every month. This is another one of my favorite programs. It's called Stellarium. Again, it is free. Just go ahead and download one called stellarium.org. And here you can set up any location and any time. So you can see what's happening in the sky tonight. Again, tonight, Jupiter, very bright in the sky. This is the largest planet in our solar system. And here's Saturn, the second largest planet in our solar system. All of them very bright. And Mars. Mars is also making an appearance on the eastern horizon in Pisces. So here's Mars. You can see 3 planets this week. Now, also in Stellarium, what you can do is to ask it to show you other planets, planets outside of a solar system. All of those green symbols everywhere, those are extrasolar planets. So there are planets orbiting some other stars, and there are billions and billions of them in our galaxy. Right now, we discovered about several thousands, but we have way more than that. Planets form together with the stars, and this is an ongoing process in our galaxy. It's happening as we speak everywhere. So it is a natural byproduct of a solar formation. That means almost every star in our galaxy, and we have billions of them, have some planets. They're tricky to see because distances are enormous, but right now we have 4,194 confirmed exoplanets, more candidates, 3,000 plus planetary systems. And actually, if you're interested, you can help. You just need to go to exoplanets.nasa.gov and you can see how you can get engaged in looking for those planetary disks to catch the planets forming as we speak. You can get engaged if you like. Here is a chart of mass of stars versus distance from the stars. Here's our sun. Let's take the mass of our sun as 1. And here is our Earth, right here. It is 1 astronomical distance from our sun, which is 150 million kilometers. And it's situated in that perfect, we call it Goldilocks Zone, which is also habitable zone, making it possible for water to be liquid on the surface of a planet. That means not too hot, not too cold, just perfect. So our sun, our Earth is in that just perfect spot. But it's not the only one. We have many other planets in our galaxy also in this perfect zone. Here's a bunch of them. For a star which is red, you have to be closer because red stars are not very hot. For really, really, really hot blue stars, you want to be somewhat away. And it looks like the most planets we found so far, potentially Earth-like planets, are orbiting yellow stars, just like ours. And again, we have a lot of them. So why are we looking specifically for planets about the size of our Earth orbiting in the habitable zones? Well, life. We are looking for life because it's possible to have life on those planets. Have we found any? Not yet, but the technology is improving, and right now we're actually capable of looking for traces of oxygen in the atmospheres. And again, oxygen means life. So research is ongoing. This is not the actual image. We don't have photographs of extrasolar planets of that resolution. This is artist's conception of Kepler 22b, the first planet that NASA's Kepler mission confirmed to orbit star's habitable zone. So some of them could have oceans, some of them could have life. And again, thousands and thousands have been discovered. You can see those for yourself. Well, actually not the planets, but stars, which we are going to be orbiting. You can go to Stellarium and again ask Stellarium to show it to you. Here's one. Remember I told you about Summer Triangle, Vega, Deneb, and Altair. Just look in the direction of signals, and right here in front of the ring, there's one of those planets. They are everywhere. There's plenty from Orion. Here is a planet orbiting Pollux, one of the twin stars in Gemini, everywhere. Way more than we show here, of course, because again, it takes a while to discover those. And here is something even more fascinating. This is field of view of Kepler mission. So here you see lots and lots and lots of extrasolar planets. Why here? Well, it's a selection bias. It's just that particular mission was looking at that patch of the sky specifically because it was convenient. And look how many we have. Now imagine all of that across everything in our skies. Again, billions and billions. Again, Summer Triangle. If you print out a sky map for August or September, locate the Summer Triangle and look right in between Deneb and Vega. And as you look at that patch of the sky, just keep in mind there are thousands and thousands of planets in there. And if you want to learn more, 2 of our astronomy courses at Grenfell are as of now fully online. That means there's no classes. Our students will get weekly assignments and weekly material which they need to study at their own pace, which is extremely convenient for most people. People who have work, who have other responsibilities, you basically can study at your own pace. So one of them is called the Foundations of Astronomy. This is first introductory astronomy course. We are going to have it this fall. And in winter, we'll have, you can think of that as part 2, 2151, stellar astronomy and astrophysics, when we're going to talk more about things like the expansion of our universe, Big Bang, and galactic collisions and supernova explosions, and all that fun. Both of those courses are fully online, and everyone is welcome. They have no prerequisites. Just keep it in mind. So I'm going to be taking questions. Angie and I will both doing that after Angie's presentations. And I am very looking forward to Angie talking us more about her work at the Dark Sky Preserve at the Gros Morne National Park. Thank you so much.
Thanks so much, Svetlana.
Hello.
Hi, Angie.
You can hear me okay? So I just start sharing my screen now. Okay. Is that okay? Can everyone hear me okay?
Yep, you're good.
Okay, perfect. Let's just There we go. Okay. There we go, hey? All right. Hi, guys. As Jennifer introduced, my name is Angie Payne, and I work for the Western Newfoundland Labrador Field Unit of Parks Canada. This is a picture you see here in the background. This is Trout River Pond. This is one of our star sites for dark skies. Before I got into this, I had no idea how lucky I had been my whole life. I grew up here, and I didn't understand that 80% of the world's population doesn't get to see the Milky Way because they live in urban areas. So it's everyday thing for us. We come home on a clear night, we look up, and the stars are millions. But it's not the same way for everyone. So dark sky preserves are here to help with that. So I'll explain to you a little bit about it. First off, Parks Canada's, I guess, our involvement with dark sky preserves. We already have 13 places designated. Most of them are dark sky preserves, which is run by the Royal Astronomical Society of Canada. One is an International Dark Sky Park, which is run by an American organization, and that's Waterton Lakes National Park, which is also a shared park. It's the International Peace Park between Waterton Lakes and Glacier National Park. So that one is an International Dark Sky Park. Our darkest dark sky preserve in Canada is in Grasslands National Park. That's in southern Saskatchewan. And the largest dark sky preserve in the world is Wood Buffalo National Park that borders on Alberta and the Northwest Territories. And I'm happy to say Parks Canada protects more dark skies than any other agency or jurisdiction in the world. So something that's really become, prevalent in Parks Canada, and it's really nice to see. So many of our sites are now looking to get dark sky designations. We've been working since 2016, and what we're looking for when we want to become a dark sky park on behalf of the RASC, they want us to be leaders in preserving the darkness for education purposes and for to help them educate people on dark skies and to preserve the dark skies. It works perfectly with our mandate. Parks Canada's mandate is to protect and present Canada's natural and cultural heritage and to foster public understanding. And this is, normally we talk about, our natural or cultural heritage and in preserving the ecological and commemorative integrity. And something interesting is that until this, we have to protect our parks and our sites in the nighttime as well. So not only protecting the ecology of our parks in the daytime, but nighttime as well. So dark skies are a big part of that. So we don't stop protecting things at night. Some examples of creatures that would be active and dependent on a nice dark sky would be little brown bat, Arctic hare, red fox. And then, of course, it's not just cute little furry things. Insects, plants, sea life, everything on Earth is dependent on darkness. So, we've got, miller. I got a picture of millers and trees and flowers. Their rhythms are attuned to the dark. A certain amount of darkness versus a certain amount of light. Even bivalves like mussels and that sort of thing, they're also dependent on darkness. So if we're going to fully protect a national park, for instance, protecting the dark skies is equally important. So in order for us to get a designation as a dark sky preserve, we have basically to fulfill two main requests. We have to be doing outreach, the sort of thing that we're doing here today. We have to offer programming to the public when they come to visit, as well as trying to reach out to people in their homes or at work or at play. We have to work with our neighboring municipalities. So Gros Morne, we have actually 7 municipalities that are not part of the park, but they're inside the confines of the park, even though they don't make up officially a part of Parks Canada land. So there's Rocky Harbour, Sally's Cove, Cowhead, Woody Point, Trout River, and that's the Glen Burnie, Birchie Head, Shoal Cove area as well, St. Paul's. So all those places we've done presentations with the town councils, and we've gotten support from all of the communities saying that they will also try to, I guess, increase the level of darkness and that they have at night. So it's, I guess, ameliorating their nighttime lighting practices. So that's what the RASC is asking of us. Part of our education, as I mentioned, this sort of thing, you know, a webinar, we will be offering stargazing kits for rental at the Discovery Center and the Visitor Center. We'll be offering public programming. We have offered special events in the past. Dr. Barkanova has been wonderfully helpful with us in training our staff, just, you know, how to give interpretive programs on dark skies. And she's also been there every time we've tried to do some sort of special event. She's been there to help us with it. So she's been incredibly helpful. For us, I guess the entire process, so we had to get the communities on board. We had to design a public education program for dark sky. The other thing that we had to do is prepare our own park, so the lighting and that sort of thing in our park. We had to make sure it was compliant to what they're asking with the Royal Astronomical Society. So in a nutshell, what they want from us is to control the color of the lights. They don't is least, I guess, invasive on biology if it's more in the yellow to red spectrum. White and blue is very disturbing. So they want us to keep our lighting on the red yellow kind of end of the color spectrum. Shielding, to have our lights shielded so that you don't have light escaping up, and they want us to keep the illuminance, so the brightness, they want us to keep it to a certain level, and they'd like for us to schedule them. So let's say our visitor center is open from 9 o'clock till 9 in the evening, 9 o'clock in the morning till 9 in the evening. Might, after that, no one's around, so we might keep the lights on a schedule and have them go off automatically at 10 p.m. at night and stay off until the rest, for the rest of the night, because lighting is not needed there. So anytime lighting is not needed, we kind of cancel out or put it on a schedule, or use motion sensor lights and that sort of thing. So it's all these different types of lighting that we've had to change. We're in the process of converting all of the light fixtures in the park. And it was my job to go around and find every light in the park. And this Excel sheet, I just got a little sample of it. I had to take a picture, I had to figure out what it was, and I had to list how many we had. And that way, that helped our assets team to say, okay, this is how much it's going to cost, this is what we need to order, and this is probably how long it's going to take. So we're kind of on a 2-year schedule now to transform all of our lighting from what we had to dark sky friendly. Thing that I had to do was go around the park and do a sky quality measurements. So it's a little light meter that was a gift from Grenfell, the former professor who was there before Dr. Barkanova. He was also very helpful. Dr. Forbes, he supplied us with the quality meter, and so I just had to go around on a clear night and measure the amount of darkness that each of our sites had. I measured in the communities, I measured in our facilities, and I measured in some of our darkest places. So we do have very, very good dark skies, even without remediation that we've begun. We do already have very good dark skies. You can see to the map here on the right of your screen, the darkest places would be kind of the bluish and the dark colors, and the worst lit places are the red and yellow and the green. So you see Gros Morne has very few, like Cornerbrook is down here. We see a little bit of red, Cornerbrook's the city, but if you go up into Gros Morne, you see there's not a whole lot of places where we get those really, really bright areas. So Gros Morne is already a good candidate. We just had a little bit of work to do, which is what we're doing right now. So sites that we picked out, another thing we had to do was identify some primary observatory sites. We picked 3 for Gros Morne because we're a large park. We're 1,805 square kilometers. So, you know, to drive from one end of the park to the other is about a 2-hour drive. So we wanted to make places that were accessible to everyone. So we picked one on the south side, which is Trout River Pond, which is where we've been doing a lot of our, well, trying to do our event, our star party, which won't happen this year, unfortunately. And so you see the quality of the sky to the east, the south, the west. What they're looking mostly for good skies to the south. So we had good skies in every direction there, but we photographer go out and take some pictures for us at night. So Trout River Pond is one of our locations. Berry Hill Pond is one of our most central locations, and it's near Rocky Harbour, so on the north side of the park. Also, very good quality stargate and night sky there. And then Green Point, which is another one, is that one of our darkest sites was Green Point, and that one is it's close to Rocky Harbour. You'd be surprised the difference in the quality. It's very high quality site, Green Point, and that's also on the north side of the park. So we're hoping to get our designation. It's been written into our management plan. So our management plan is basically our guidelines. We do them up. This one is going to be a guideline for the next 10 years, and we've made I guess commitments to having certain things done, you know, in 2 years, and 3 years, and 5 years. So our commitment is to have the dark sky designation within, I think it was 5 years from last year. So another few years, and we should have the dark sky dark sky preserve designation all ready to go. So yeah, I guess that's my part of the presentation. I hope I haven't gone over top. So yeah, if you guys have any questions, Dr. Barkanova, we'll be here.
Awesome. Thank you so much for that. So I have one question that came in here. It's for Angie. And it says, do humans respond differently to the different color/intensities of light? So he says he feels blue/white light bothers him more in comparison to like orange and yellow light.
Yeah, we're as sensitive as any other to light, and they say, in fact, when they recommend people not having screen time before bed, if you have trouble sleeping, it's because there's a lot of blue light in screens, for instance. So that will throw off your rhythms, your circadian rhythms. And in fact, interestingly, it takes your eyes about 20 minutes to adjust to darkness, and like to really adjust. You know, like when you turn off a light, you can't see anything for a little while, but then slowly things start to you can make things out because your night vision kicks in. But it takes 20 minutes to get it like fully kicked in, and the slightest little bit of light will ruin that again for another 20 minutes. So if you're ever, say, stargazing and you need to read something like a map or something, they recommend using a red light because the red light won't affect your night vision. And if you keep all of your lighting on the yellow to red spectrum, you should have a little less trouble with sleep and stuff and that sort of thing. So yes, humans are very much affected by the color of light.
Awesome, thanks. And then this next question is for Svetlana. For you talked about the discovery of Earth-type planets and how are they different from other planets, and like, is there a size comparison that you need to have, or is the spheres that you mentioned, like, how long does it take to differentiate them?
That's a very good question. So basically we have two major types of planets, Jovian planets and terrestrial planets. In our own solar system, we have 4 terrestrial planets, which are small and rocky. So Mercury, Venus, Earth, and Mars, those are terrestrial planets. And we have 4 giant Jovian planets, Jupiter, such as Jupiter and Saturn. And planets as Jupiter and Saturn are not that interesting because they're not good candidates for hosting life. So we're interested in smaller planets, planets like our Earth. That means the first thing we're looking when we're looking for extrasolar planets is size. We don't want them to be too large. Size of Earth may be a little bit larger, but not too large. And again, it's very important for them to be in habitable zones, so not too close, not too far from their stars. As for finding them, it is much harder finding terrestrial-sized planets than Jovians because they're smaller. They're really tricky to catch. There are methods for that. We are getting better and better, but so far, most extrasolar planets discovered are big Jovian planets, just because they're easier to see. But that field is progressing really quickly. If you go to the NASA website dedicated specifically to that search, they're changing their count pretty much every day. And again, if you're interested in helping, they're looking for people to engage.
Awesome, thank you. So the next question is for Angie, and it's, would you consider light pollution to be an environmental issue? And like, would other conservationists and environmentalists agree?
So for sure, yeah, it's definitely an environmental problem because it throws so many things off. We all evolved with a nighttime and a daytime, and there's important things that happen in our bodies or in a plant system or in a mammal, a bird, an insect, all those important things that happen in the daytime and important things that happen in the nighttime, rhythms and that sort of thing, and that's what we evolved to, and we've kind of ruined that with light pollution. So for instance, something very simple is migration. With birds, they believe that migration patterns could even be thrown off by light pollution with birds and that sort of thing. That's just a very simple one. Plants, we all know that we can put grow lights on plants inside, and we can grow them at any time of year. And that's the same thing with light pollution outside. Plants, their natural cues are thrown off. So yeah, it's most definitely an environmental pollution. It's a different way of thinking of it, I guess, but definitely an environmental concern.
Awesome. This one's for Svetlana, and it's pretty simple. It's, when will the observatory be open again to the public?
Can you tell me when are we going to have a vaccine or the end of a pandemic? Good question. I have no way of telling that. The problem with observatory is that to actually look through the telescope, you have to put your face right in front of the eyepiece. And right now, there is no way for us to sanitize that equipment. It's just, we fought very hard about that, but it's just not possible. But what I was discussing with Angie just before we started this presentation is that we can still do night sky observation sessions in a different way. We can do that outside. We can all observe a beautiful star-filled sky together. We'll just have to keep our distance at 2 meters. We'll have our own individual printed out maps, and I could navigate through the night sky with a laser pointer. So we are not going to be in a physical contact. We won't be using the telescopes, unfortunately. That's not possible at the moment, but we can still enjoy the sky together.
Yeah, we could even get people to bring binoculars, right, Dr. Barkanova? That even binoculars are helpful.
As long as we are not sharing them, our own individual binoculars.
Right.
Well, that'd be a great opportunity for people. The next Svetlana again, and it says, can you comment on what is happening with the apparent dimming of beetlejuice in Orion in recent months and NASA's Hubble telescope in determining that?
I don't quite. Apparent dimming of betelgeuse in Orion. Betelgeuse is a highly evolved star. It is actually a star at the very late stages of its lifespan. Stars as our sun are fusing hydrogen in their cores to generate heat, to generate new elements. That takes a while, but at some point will expand and become red giants like Betelgeuse. Betelgeuse is a red giant. But at some point that will stop too. Nothing lasts forever, not even in the sky, and it will dim. And eventually the star will be, well, dead. Although it's not that sad, because as stars die, they redistribute the material in the galaxy, which becomes the material for the new planetary formation. As I outlined today, is that new stars with planets are constantly forming in our galaxy. I guess it's a circle of life for our stars. So I suppose it's possible that Betelgeuse is just at that stage when it's, well, almost done.
Awesome. This one is for Angie. It says, what is the best time to see the night sky in Newfoundland on both the East Coast, if you know?
Best time, I guess, season, I guess, asking, I guess.
Season or time of nighttime, both.
I've most of what I've learned was from Dr. Barkanova. Summer is wonderful, and fall too. You get the early nights, and Dr. Barkanova, feel free to step in at any point. Summer nights, you get those, the constellations that Dr. Barkanova was talking about earlier. Those very easily identifiable stars, but I would argue any time of year is beautiful. You don't get quite as dark when there's snow, but I don't think that affects it too much, right? But you get, as Dr. Barkanova mentioned earlier, you get different constellations that are seen in the sky at different times of year. So, for instance, you don't get to see Orion right now unless you get up about 3 or 4 o'clock in the morning. But in the winter, you can go out and see Orion, earlier in the nighttime. So I would say any time of year, and depending on what constellations you'd like to see. One thing I have learned throughout this is pretty cool. What you see in the very early morning sky is the precursor you're going to see in the evening. Sky early in the morning, you know that Orion is going to come and be an evening constellation in the next season. So that's pretty cool. Yeah, I don't have anything to that, Dr. Barkanova.
Best time is anytime. The sky is
Yeah.
constantly changing. There is always something to see. If you know what to see exactly on that day, just print out your own sky map as from the website I showed you, and there is always something. So I suppose that's up to a personal preference. I prefer summer nights because I have no problem being up at midnight, and I don't like cold. But in winter, the dark sky will come earlier. So I suppose that would be easier if you're observing with kids.
I nice down sleeping bag. And
Next question is for Svetlana. You mentioned apps and we can get them for each month. Do they kind of follow a cycle? So like the same things that you can see in this August will be the same things you see next August, or is it constantly changing?
The constellations are the same, it is the cycle, but the planets are less predictable because they move quickly. Some of them move quickly. Mercury, Mars, Venus will be changing positions month to month and so on. So I would say still get a new map every month because there is so much more of them. There is meteor showers, there are phases of the moon, all kinds of interesting events. You'll get a schedule for that.
Awesome. No, that's a good idea. I'm downloading my map right away now. And so I guess this is for Svetlana. So do you or can you use the telescope or the Dark Sky Preserve to search for new exoplanets like the Citizen Science Initiative mentioned on the NASA website? Which is best? Telescope or the Dark Sky Preserve?
This is a little bit more complicated than that because it's not just looking at random stars out there. You need to know where to look for specifically, and you need to look for a very, very, very long time. We're talking about hundreds of hours of exposure. So the most practical way is, instead of collecting your own data, leave it to professional astronomers who do that for us, their jobs full time. Go to the NASA website and get to their database. But they still need human eye. So they have very, very extensive information out there, but they need help with people looking through that information. Something that robots can do for us. We still need humans to help.
Awesome. And the next question is from Angie. And it says, you talked about the sky quality that you were taking in different areas of Gros Morne. Is there specific levels that you need to have for the dark sky designation? Or, does Gros Morne have to, like you do have to put remediation, is there extra remediation that needs to happen to do that then?
not for Gros Morne. The most remediation that we need to do is with our facilities. So we would have, say, our campgrounds or our administration compound. So we have lights and security lights that need to be remediated there. Yes, there is a certain level that we're looking for. And now I'm gonna go back. I haven't read this for a little while now. The highest reading you can pass, I think, is 21, I believe, 21 or 22, something like that. Your typical, I think, at Rocky Harbor, we were getting, I think, around 17, 18 there. But, typically around the park, we were getting 19, 20, like that. And I was lucky. I got to go on to do some field work one summer when I was doing the measurements. So I just out of curiosity, I took the sky quality meter up into the hills, up into the long range mountains where there's absolutely zero light, and I got near 22 up there. So the bulk of our park is, our highway runs right along the edge, the coast of the park. So So the bulk of our light comes from the communities and, you know, the highway. So the rest of the park, which is, you know, you got the lowlands going, then you hit the highlands. Most of the park is in a very, very, very dark zone, as you can see on that map that I was showing you earlier. So to answer your question, I believe we're looking for measurements. If memory serves me, it's around 20, I think, is probably the minimum for what you want for your core. And then your communities are, you know, it's a little bit lower, as would be expected, because you have people living there and street lights and that sort of thing.
I think we all should strive to make potentially dark sky sites as dark as possible. Just keep in mind that light pollution is pollution. And we have gotten so much better about being aware of other kinds of pollutions. People don't leave their trash lying around anymore. We're excellent at that. But again, if you're camping and if you don't need those lights, don't use them. I have my neighbors at the cabin, they're on the solar lights. They have pretty solar lights everywhere, even if they're not there. They're not there for months, but the lights are on. That really bugs me. So just be aware. Don't use lights if you need them, of course, but turn them off whenever you can.
And I just like that. I guess the cost is so cheap now for those LED lights. So I've noticed so many people, even graveyards, like people will be putting like lights on their family's headstones and things like that these days. And it's a nice gesture, but every little light, it's, you know, a very cheap light, doesn't use much energy, but it creates so much light, these LED lights. So it's becoming more and more prolific around. And I guess people are a little bit addicted to light. They maybe perhaps a little bit scared of the dark more than we used to be. I don't know. When the dark is a wonderful thing.
Awesome. I think it might have been answered, but it was asked was someone said they had seen the Milky Way really clearly at Port Peninsula camping, and they wanted to know if there's a perfect place in Gros Morne to observe it. I know you mentioned the long range mountains, but is there another specific place that'd be great?
Well, I'll say something, and Dr. Barkanova, you can jump in, but from my experience, anywhere outside the communities in Gros Morne, you can see the Milky Way. It's just beautiful, you know, kind of so many stars. It looks almost like a white stream, right? So luckily, pretty much anywhere in Gros Morne is a great place to see the Milky Way.
Yeah, Gros Morne is awesome. We are so lucky to have it nearby.
Awesome. I think that's all the questions we have. So I just want to say thank you again to Dr. Barkanova and for on here and presenting and sharing some information with the Dark Sky Preserve and physics and all the great things we can see in our sky. So thank you guys so much for doing this today.
Thank you. Bye.
Bye.